Okay, hello everybody. My name is Sjurseth, and I'm going to be talking to you today about modern trends in API architecture. I'm an outbound product manager for Apogee, and I've been working with Apogee for a long time. So I've seen certain trends come and go. So we're going to talk about those different trends and styles, and I'll even give a solution example later, and then hopefully we'll have some good Q&A. So again, introduction, API styles, solution example, and the Q&A to kind of follow up at the end. So what is an API really? So I think an API is often described by us as a doorway into your enterprise. And I think that's true, but I think an API is a lot more than that. An API is also the doors between different organizations in your enterprise, and the doors between different departments, remote controllable doors, doors into your canteen. They're absolutely everywhere, and they're a fundamental part of how we parcel up and distribute different types of teams and ways of working. And more to the point, we find that 83% of all web traffic is in fact API traffic. So we think of these doorways as something that's supplying the building, but it's actually the doorways, the APIs in this case themselves, that are fundamentally what make the web work. So it's not the other way around. The web is built, web applications and mobile applications are built to consume APIs. Rather, the APIs are there, they're the network upon which everything is built, and we see the surfacing of different types of applications based on those. And so we feed the API system in different API styles first and foremost before we actually build those applications upon which we're so used to using. Okay, a note on just a couple different API styles. So first of all, restful APIs. Obviously, these are still fundamentally the most common type of API pattern that we see today. I'm sure these are the types of APIs that most of the people in the audience here are used to working. Fundamentally, there's a bunch of front-end systems that are consuming APIs. They will make an HTTP style call using an HTTP verb, perhaps with a payload if they're doing something like a post or put, to some sort of back-end system. And these back-end systems can be very mediated by some sort of API platform here in the middle to be ultimately consumed and delivered to whatever that consuming application here is on the left. So this continues to be the first foray into APIs for most companies. I think a few years ago, we were still looking at a world where SOAP was the underpinning of a lot of this. And we still indeed see a lot of SOAP, but first and foremost, RESTful APIs are where it's at today. Another emerging pattern is that of GraphQL. So if you're not familiar, GraphQL is an approach to kind of make the way you access APIs and the type of data that you get when you access an API, put that power into the hands of the consumer. So here in this case, we see an example that's making a Star Wars call. So it's querying for a human with an ID of 1,000. It's going to ask for the name of whoever that is and the height of whoever that is, and please return that in feet. And what we get is a response with, it's a data packet coming back with human, name Luke Skywalker, and then of course a height there, showing Mark Hamill's height. And this is interesting because where in the RESTful API world, all that power lies in how we create the contract, often called an open API, spec, doc, to manage that. Here, this is 100% in the hands of the consumer. And I want to make the argument that, and I'm beginning to see this more and more, that means that GraphQL is the ultimate way to build a BFF. And a BFF, if you're not familiar, is this notion of a backend for a front end. So you might have different types of applications that ultimately want to access the same data, but they want to access it in different ways. And for a couple of years now, we've seen organizations make an attempt to create bespoke APIs to serve the needs of those various and sundry applications directly according to how they wanted to see their own payloads. But with GraphQL, I don't have to do that. I can create a single endpoint, and that single endpoint gives the power to the consumer to, in a common query language, ask for precisely what they want and then get that back in that standard format. Also, GraphQL is interesting because oftentimes it builds on top of an existing array of RESTful services. Sometimes other things, sometimes direct application backends. But we're seeing definitely a pattern here where you build REST first. On the backs of a successful RESTful approach, you begin to move into a GraphQL approach that builds on that as well. Another API style is that of GRPC. GRPC is a Google standard for remote procedure calls. And it's notable, I think, first and foremost, because we see it a lot internally at Google, and we're beginning to see many gaming organizations in particular use it. And why is that? Well, it's because it's super high performant. It's based on HTTP2, which means it directly uses binary payload types. And it also supports bidirectional streaming, right? So if I want to create a connection and stream across that, that's the kind of thing that you weren't really able to do in any kind of meaningful way using REST. Yes, there's things like WebSockets, but for the most part, that wasn't allowed in the RESTful paradigm. But with gRPC, I can create a socket that will stay up and allow me to stream data down, and potentially in both directions. Also, a lot of people like gRPC because it comes with its own standard way of handling it. So what this might look like is I define a service in what's called a protofile, and that protofile is a standard description format for that. It's a bit like an open API specification doc you might have for a RESTful API. But I would say a closer analogy is that of a WSDL for a SOAP service, or perhaps even a header file for an old C or C++ program you might be compiling. It describes all the methods and the signatures that you would expect for everything that you're going to have for every type of interaction. Once you have that, you can generate client stub code, and generate the server, create the buffers, then you can begin invoking it. And then so any given service can invoke different types of backends, and there's no inherent reason to use the same code language for the backend as the front end. So it's absolutely a polyglot style environment in use case. And what that might look like is that with your protobuf, it ends up naming the syntax and again naming these different types of message formats that you might get back and the attributes that are going to be associated with them. One thing about gRPC, just as a separate note, is it's not particularly useful if you want to empower your non-code enabled staff to use these APIs. So in a world where we begin to see a move toward democratization of APIs, gRPC isn't great for that. Where gRPC is particularly valuable is when there's specific demands on high speed, low latency, high volume style workloads, and where you want to enforce the payloads with something strong like a protobuf file. This makes all that really, really easy. Okay, now I want to jump into a solution example, but this time an example that has a whole other type of API paradigm that's kind of not new, but it's made a resurgence, and that's that of events. So we can imagine that we might have a retail organization that the front-end architecture, an API platform of some kind in the middle, mediating for services that lie beneath it. And these services might ultimately form the basis of a headless retail application system, right? So custom servers that are built on APIs, purchasing systems, the headless commerce system itself, which kind of lies beneath it, these APIs, email and event systems that are connected to that, and some type of event broker that's going to manage these events. And there's lots of these today. So I think most commonly we hear of event brokers such as Kafka from Confluent, or Solace from Solace, but even PubSub from Google is an alternative example of that. But actually, this type of event system is much older, right? So we have message-based systems in the form of MQ and these types of topics and brokers that really rely on the same basic type of system in terms of what it looks like to receive these. But I want to make the argument that building a complex system like supplying a fully featured retail environment for end consumers, and for the logistics and for the point of sale systems and purchasing systems on the back end, ultimately needs to be a combination of RESTful kind of HTTP style driven elements and solution elements. So we're going to break that down. So we might start with a system that begins with browsing and shopping. That's mediated through an API platform. And on the back end, we have our headless commerce system, which is ultimately creating those APIs for the catalog system that's allowing that user browser to browse through and look up different pieces. At some point, the end user decides that they're ready to make a purchase, and now they might begin to use payment service APIs to start that purchasing system, right? Just to start the actual purchase of what they're going to buy. That purchase itself might create an event. That event then can go to some sort of purchases channel. And that channel then can inform a number of different subscribers. And this list here is kept purposefully very, very simplistic, but obviously could be a lot longer. But once the purchase is done, then there might be a receipt that's going to be emailed. We might notify logistics that there's something that needs to be ready to be packaged up and sent to the purchaser in this case. And then finally, once we've done that, and this, by the way, might go through a number of iterations of different stop points along the way as the item gets closer and closer to the end to the end consumer, we send an event notifying the consumer that it's ready to be picked up, or indeed that it's been delivered outside their door, and perhaps even multiple events to do different types of these. And by the way, all along the way, we still have order services APIs that are connected to the web experience, or perhaps the mobile experience, that are ultimately connected back to the headless commerce system. That's a non-event driven style system in the sense of these channel-based systems that's going to go directly to that source, that database source probably that's holding the data, to let you know what the status is of your actual delivery of what you purchased. So to build this type of use case ends up being a comprehensive use of both probably RESTful, could be GraphQL type services, in concert with something that looks like an event-driven system to get the complete delivery. Okay, and now I just want to talk a bit about a service mesh. So service mesh isn't an API style, but I think it's important to talk about the service mesh because it's something that's increasingly important today as we talk about a variety of styles and a variety of consuming patterns that we're seeing between developers and producers in the world today. First and foremost, there's a problem of something that we like to call ingress, right? So if your service mesh is deployed as it usually is on a orchestrated containerization platform such as Kubernetes, then you're going to have to deal with these individual services and the access to them through that ingress point to that Kubernetes environment. And that usually, or quite often, looks like an API, the RESTful APIs that I began today's presentation with. How these services communicate with one another, however, can vary. So we see every one of those trends that I've mentioned above inside the mesh. So I see trends where we see GRPC connectivity between these because they're in the mesh, they expect low latency, and they want to do extremely high volumes, and they want to do stateful bi-direction streaming as part of what they're building. And doing that inside the mesh makes a lot of sense, where having an explosive volume increasing application that's taking stateful connections to the whole world would be difficult to scale up from an architectural perspective. I also see event systems. So putting an event system beneath the mesh and using that as the event layer between services is also a common pattern that we see. And I think we're going to find new and more interesting ways over time for how each and every one of these different API styles is ultimately realized and implemented directly in the mesh. And now just to end this, I'm going to talk a little bit about Apogee. That's the organization I work with in terms of what we do with Apogee and how we're kind of trying to address these different areas. So Apogee itself is a combination of multiple functionality areas. So first and foremost, developer services. So developers need to be empowered to find the APIs they want to use, probably in some sort of catalog, perhaps get a client or SDK to use it. And there might be a marketplace, combining productization and monetization, indeed, for those APIs themselves. Analytics services, so everything that traverses so everything these developers do should generate analytics information, and indeed any runtime pieces that generate also data that should end up in this analytics piece that will inform producers and incidentally could inform the consuming developer as well about the success and failures of the initiative that they're driving. And that could be anything from just monitoring the API itself to monitoring the overall API program and metrics that you've been building for a while in terms of every one of the products you've built and so on. Management services to make sure that we provide security, transformative ability, perhaps integration pieces, right? So we might be combining APIs with long-running traditional database-style connectivity in the background, or even iPaaS systems. And handling all that needs to be a core part of what we do. And finally, we have the runtime itself, right? And so then that's an enterprise gateway that we can run either cloud-hosted or as a hybrid program that you could run anywhere you like. And now more and more work we're beginning to do with Envoy. So Envoy as the single most popular reverse proxy system in the world, and it forms the core of Istio, is increasingly becoming a go-to way to provide agile, quick, and lightweight enforcement for API traffic and analytics, kind of anywhere you want to run that. Sometimes it's something embedded in a mesh, like I alluded to before in the previous slide, and sometimes as a standalone vanilla runtime that can handle any one of these pieces. And if we do this right, then what we end up with is full lifecycle API management. So we believe strongly in beginning with design. Once we've designed, and that design phase, by the way, should be an invitation between the producer of whatever API you're trying to create and the consumer of that API. So they can meet. Once we meet, they can each begin to develop. So on the producer side, we can develop according to whatever design specification we created. And likewise, we could use that design specification to drive how the consumer is going to build whatever custom application they're using on top of that. Secure this in as way as possible, publish so that these developers can find it and onboard themselves on their own. This needs to scale to a potentially very large number of developers, but also incidentally scale in a sense to prevent abusive attacks that might come on the back end, right? So we need to make sure that we're not overloading our back end with too much traffic, and we want to make sure that we're blocking those users that shouldn't have access at all. Monitor and analyze everything we do, and theoretically, if we can get there, we may monetize the API calls themselves in earnest in order to make whatever we're building with these APIs in any one of those styles and turn that into a product offering in its own right. Okay, and with that, I'm going to turn it over to Q&A, and I look forward to some interesting questions. I see. What are some GRPC advantages over REST API? I would say that there's kind of advantages in both directions. The first is that GRPC is something that requires strict adherence to a particular payload. That is you have that protobuf. That protobuf defines specific types of payload signatures that it's going to accept and that it's going to respond with. And for particular applications where you're really worried about that, financial services is an example that comes to mind. It becomes a very comforting way to develop applications where you're not worried that somebody's going to use JSON and replace an integer with a string, for example. So that's one advantage. Another advantage is notably as I said, where performance is of a primary concern. So where we see that is bidirectional services. I did mention gaming, right? Where gaming is going to be looking to stream real-time data, and incidentally, that type of real-time data to an initially unknown number of subscribers, but in a way that needs to scale to as many as possible. And that's not something RESTful APIs actually handle as well. The reverse is also true, though, right? So if you want to, as a human, make a call to an endpoint and just read the data that it's returning and try to figure out how to use that in your own creative way, you can do that with REST, and that's not something you could do with gRPC. gRPC requires a more programmatic approach to kind of make that possible. I see another question in terms of, the question is, what's the overhead that GraphQL adds to the API request payload? Are there any specific changes to SLO monitoring as compared to the normal REST API pattern? Yeah, so I wouldn't say GraphQL doesn't necessarily per se add anything to a request payload. But it can, right? So where if you start to see payloads in a RESTful world, which you'll typically implement is paging, right? So you'll create a way to page your results, limit the number of results you get back, and handle that way. And you could do that with GraphQL, but it's not something that's inherently built in necessarily. So you could end up with very large payloads that are returned. But it's not always the case. And so predicting the amount of returns that you're going to get back with a GraphQL request can be difficult because of something called fan out. So by virtue of how you plug in that query and that custom query language, it can you can end up with a not necessarily predictive amount of result sets, because that in turn can spin a bunch of other calls on the back end. And then there was a question in terms of monitoring compared to normal. Yeah, I think the monitoring becomes interesting because of that fan out piece. Notably, some people that are building GraphQL applications are worried that they're going to see significant back-end pressure because of how the fan out piece might work, right? So you can create as complicated of a single GraphQL query as you like. I mean, you could try to prevent that. In fact, Apogee provides ways to prevent query complexity on behalf of GraphQL. But barring that, GraphQL by itself doesn't have any native way to kind of stop that. And actually, GraphQL is rather agnostic in terms of how you add this type of prevention, and rather wants to see those enforcements come for whatever's behind of GraphQL, or if you can, put something in front of it like an API management platform such as Apogee. Another question, what is the best API design approach? Well, that is a very open-ended question. I think it depends. Depending on how concrete and deep into an answer we want to get, it depends very much on the type of API that you're trying to build for. That's one. Secondly, I would say at a kind of higher level, you may remember that one of my slides on Apogee, I started with design. There's a sort of design in terms of how you should begin to think about what you're going to build for your APIs. So, and that design piece is an opportunity to create a contract. So in the RESTful world, we think of contracts as an open API specification doc. In GraphQL, we might think of that as the schema, right? So what types of query am I allowed to query for? In the GRPC world, I might think of that as the protobuf that's going to define exactly what I can get out of a particular service and in what format I'm going to get those pieces. But the design phase says before I go and I write that contract, so the protobuf, the schema, the open API specification doc, I invite the consumer and the producer of the API to meet to kind of discuss this, just like you would with any real contract in the real world between somebody purchasing something and somebody selling something. You provide a method for people to agree and come to that type of agreement, and building an API from that principle, in my humble opinion, is the best way to go about designing APIs. In terms of the specifics on a per API basis, it's a really big topic. I would say that probably something that we'd have to save for a per API type and a per implementation style discussion. Let's see, another one. Is there any evidence in modern applications of XML or modern SOAP? Yeah, it's funny. Everyone hates XML, and the world's moved to JSON, and now we're beginning to move from JSON to YAML. But I don't know that anyone actually thinks that any of these are any easier to edit, by hand at least. In particular, YAML can be really very, very difficult to edit. So I still see plenty of XML in the world. A lot of this is coming from older systems, and a lot of this is coming from older consumers. So there's still a really big part of the world that developed massive applications 20 years ago where XML was the way you were going to do that, and that are not IT-driven organizations. They're brick and mortar institutions that are handling logistics and or are handling building cogs for some larger organization and are not the least bit interested in upgrading to that. And those organizations are still using and consuming XML, and that puts demands on the producers of APIs to build features that include that. And so you'll see something that we've seen actually for 10 years now, where an organization will build an API that supports both XML and JSON, and then you can handle that by either using an accept header to accept JSON versus XML, or that they specify some additional query parameter to accept one or the other. But definitely something I still see. Yes, it's beginning to decline, but as I said, there's some holdouts, notably in these kind of older institutions. See, another question: how is gRPC API different from Fast API and REST API? I mean, so gRPC is different from all these others basically because of the binary payload and the reliance on HTTP2. So it fundamentally creates a socket and to that end system, and then keeps that socket as a piece of pipe that's up if you need it in order to do a bidirectional communication. And that's simply not something you could do with the likes of REST API. REST API is going to be if you want to build a RESTful application that's going to expect a potential return between now and 5 minutes, then you end up polling, right? So you're going to poll every few seconds, once a minute, until you get something back. An alternative approach to that would be to use WebSockets. WebSockets is another way to do the same thing, but even with a WebSocket, you're ultimately pinning some sort of pipe up to between the client and and the server, waiting for data to come back down that pipe on the other end. gRPC provides a modern way to do precisely the same thing, but in a way that's very code specific and therefore code optimized. Because the whole payload is binary, it's expecting serialization and deserialization on either end of that, using the protobuf to guide that unmarshalling, either on the other end of it. And that means that you have a very efficient and effective way to kind of move data objects around between systems. Next, will you get a copy of the presentation? Oh, that's a good question. I don't think so, but I believe the video will be available on demand and it can be uploaded to the Innovators YouTube playlist. But I'm afraid I don't think we can provide the presentation. Okay, so with EDA gaining traction, are you seeing API use decline now or in the future? That's a great question. No, I don't think so. So as I truly believe that there are legitimate use cases both for event-driven systems that rely on something like event-driven architecture or EDA, and systems that absolutely expect an immediate response, and an immediate response that follows a contract in the form of an open API specification doc. So at the moment, no, I'm not seeing any decline whatsoever, and I wouldn't. In fact, honestly, the API market is a market to win. There's every day there are more and more APIs. As I pointed out at the very beginning of my presentation, overwhelmingly the traffic that constitutes what we see on the web is API traffic. It's not static files and images and HTML. It's actually the APIs themselves that overwhelmingly constitute that traffic that we see there. And so I'm not seeing APIs diminish. They're still growing. The growth of the market is still rapidly increasing. The EDA piece is interesting because it marks a way to do things that you wouldn't want to handle in an API style way anyway, right? So if I want to send a message and I want that message to be received by an unknown number of subscribers who can do different things based on what they decide to do with that message that I send them, I don't have a clean way to handle that with a RESTful API or GraphQL or even a gRPC style API. There's no good way for me to handle that. If I want an arbitrary number of subscribers to do something, to respond to an event, that's a difficult thing for me to build without using something that looks like an EDA style paradigm. And so I would expect them both to increase significantly starting now and going long into the future, or at least until the next big paradigm shift happens, and who knows what that's going to be. Okay, So I mentioned something about Apogee. There's a question about how does Apogee, how is Apogee different from, say, API gateway and endpoints, and when might I use one or the other? So I'll say that there's a bit of fitness for purpose but between these. So there are certainly certain areas where API gateway really shines with respect to its ability to work with serverless functions that you might run on top of GCP, right? So if I want to run Cloud Run, I want to run Cloud Functions, and I want a quick and easy gateway that's going to mediate access to Cloud Run and do it natively, that sort of understand the service account approach to accessing those pieces. And incidentally, I'm not worried, or at present time, I'm not concerned with creating an engagement layer to manage the developers that are getting access, right? So it's an internal project where I'm using serverless functions, and I want to quickly create a way to handle that. API gateway is phenomenal for that, and it doesn't have the same on ramp that you might expect with something like Apogee. Likewise, for cloud endpoints, if I'm specifically building gRPC based services, and I definitely want to enable the local development in a local environment, and for some reason I don't want to use Apogee for that. I don't want to use Apogee. I want to use a lightweight system, and I want to be able to do that development on my local machine with enforcement coming from the control plane for cloud endpoint. Cloud endpoints provides a way to do that for gRPC services, and that might be where I can use that. Okay. Can you please describe a little about the stages of modernizing a monolith API? That's a great question. I would say, well, first of all, any given, in my opinion, any given API shouldn't need to be modernized. It shouldn't be conceived as a monolith, right? So you might have a monolith application that's hosting a number of APIs, but one ought not have one gigantic API that's all part of the same API. And if you do, then that points to a bad design, right? So there was a question earlier that I didn't go into too much depth on in terms of how do you do design API, and I pointed out that I thought you should begin on design and involve the consumers and the producers in the conversation so they can kind of discuss the best ways to build that are going to be fruitful for both parties. But if you end up with let's say a less than ideal, hard to understand API that's a single service that has everything baked into it, then I would say the first step is to abstract away from that, right? So you can wrap that API. And honestly, this prescription that I'm going to give now is the same for how you break up a monolith into microservices. There's lots of ways to do this. It's always really hard at some point, but I mean, I think at a high level, you break down that part that's monolithic and difficult to use. You break that part down into smaller pieces, and doing that with a wrapping API around it to make that simpler buys you the agility to slowly rework the underlying monolith that lies behind it. So if it really is a single service that's running that API, and that single service is not constituted by a single API runtime beneath it, then the good news there then is that it's easier, right? You can build, you might not even need to build the wrapping API. You build an API that will talk to each one of those individual services. If it's, as I feel like it probably is, rather, it's just a giant monolithic runtime that's doing everything all by itself, and it's not broken apart. Then I say you start with an API that maps for the future of what those microservices are going to look like. So create a taxonomy for the microservices that are going to be comprised of bounded context, right? So this is a domain-driven design principle, but it should follow not only how you build a runtime in the microservices, but also how you're thinking about accessing that API and the data that it constitutes, right? So take those systems and begin to plan out what that data should look like and what the interaction should look like with the consuming parties, and build that API, and then for now map it to the existing world. And then as that's mapped to the existing world, over time you swap out those older services for new ones. And that's not as easy as I just made it sound. Obviously, sometimes part of the problem with these monolithic applications is that the underlying implementation is entangled in other pieces. And so you might have to build an additional layer of disentanglement that for a while maintains that entangled behavior that you have between these services while completely recreating a new location for the underlying data in an unentangled microservice compliant way stands. And then with that, with the API on top of it, means you can get to a place where you could be agile. That was a very complicated question. I hope I provided some insight there. Let's see. How often does your team use API metrics and resource models? Oh, we use it for absolutely everything that we do. So we use our API models to govern how growth is with our own platform, how success or failures that we're seeing with different parts of our platform, how the management pieces that underpin the kind of the back end side of how everything that works with, all the way from rolling out an individual provision runtime that's on GCP to the enabled features that allow customers to take something like hybrid and deploy it, to the more production-ready side of things where a customer in earnest is using our platform to deploy APIs in their own right and keep track of those. And that's, by the way, that's how Apogee uses it, but that's also core and part and parcel to how Google does everything that they're doing. These APIs drive specific and computationally interesting metrics that show us exactly how things are being consumed. So all the time, I think it's a core principle to proper API management. If you're not doing that, all you have is a gateway. You don't have an API management system. Okay. Let's see. Is there any more questions? No. Let's see. Good day. Please, in telecoms GSM applications where interactive session is required with a limited time frame for services over protocol like USSD, SMS, right? What API styles on Apogee is best for such an interactive service for best performance? So we have all kinds of telco customers where we'll wrap different services that they're using. Business-based systems versus the operational side systems. We wrap those in REST all the time. I think frankly, I see a lot of SOAP in that part of the telco world still as well, where there'll be a mediation layer where we're essentially wrapping what's presumptively a SOAP backend and a suite of SOAP backend systems with a RESTful layer that lies on top of it. For USSD, for these more streaming style systems, yeah, if you want to modernize that part of the backend, I might use GRPC for that. So not for the side that you want to create an open, and it doesn't have to be open to the whole world, but open to wider parts of the organization style interface for. Rather are maximizing the efficiencies and deliveries of that data. I might use gRPC for that. I might still use a RESTful paradigm for it in a controlled data channel style way, right? Where I use a RESTful pattern to create the channel, and then I can use another streaming system. I might even use an EDA to handle a different part of a streaming use case for that. And the controlled data channel isn't familiar. It's this idea that you decide to go view a film online, that you're walked through a process to begin viewing the film online, and then at some point the client switches to the data channel where the data is going to keep going, and then every few minutes another control API call is made to make sure you still have access to do so before the streaming picks up. It's the way you used to see Netflix pause periodically when you were viewing content. So, okay, next question. Is Graph taking over REST? What would I recommend? Okay, this is a great question, and I'm going to provide a bunch of my own opinion. So I don't think that REST is going away. And I don't think REST is going away because, at least today, because there's still a couple of, in my humble opinion, problems with how GraphQL works. So GraphQL is a delight to work with. I've built systems that were built on GraphQL in a previous life for what I was doing in IT. And for building a way for a consuming application to take data from 13 disparate sources and compile that all down to a single query that executes against a single endpoint is absolutely marvelous. And it makes that type of development much, much easier. And it puts that power in the hands of the consumer, which is right where you want it. The reverse, though, if I want to enable what in GraphQL is called a mutation, right? So if I want to create, I'm not just reading and consuming data and what we call a query, I'm actually going to try and go write data back to the system. GraphQL, you can still do that in GraphQL, right? So I can create a mutation, that's a query that's going to go and update or insert or in any way modify data that's on the back end, but it does so without any transaction integrity. And I find that a little worrisome. So so depending on what I was doing, I might be more willing or less willing to do that. So obviously for a financial services company, I would be extremely unwilling to use GraphQL to mediate those types of calls because it feels really, really dangerous. At least not without creating it would have to be at this point, bespoke way to handle that at the GraphQL layer to keep track of what ultimately is turning into a distributed transaction. So you're managing writes up to different backends to the system. And I don't think GraphQL is ready for that. And so for that reason, my recommendation would be use GraphQL when you would otherwise be inclined to go down a BFF path, so a back-end for front-end path. So use that in order to empower the developers to quickly get access to that data. Use that for a data mesh scenario. So if you've got a bunch of disparate sources of data in various clouds and some on-prem, and you're trying to create a way to combine access to that data and meter that access, combine API management with GraphQL because it provides a phenomenal way to control those pieces. But as soon as you have transactional data where you want to write something back or commit something or delete something, I would be inclined to fall back to REST for those pieces. Okay, I think that's it. I hope that was helpful and interesting for everybody. And thanks, everybody.